The question is, find the signal x of n whose dtft is xp of omega equals to 2 e power minus j omega divided by 1 minus 0.25 e power minus j2 omega. Here we can write the z transform of xp of omega as below. Xp of z equals to 2z power minus 1 divided by 1 minus 0.25 z power minus 2 if z equals to e power minus j omega. This equation we can simplify like this: 2z power minus 1 minus 0.5 z inverse 1 plus 0.5 z inverse. So 2z divided by z minus 0.5 z plus 0.5. If in order to get the x of n, we can take the inverse transform of this equation by applying a partial fraction expansion. Then we can get x of n as 2 into 0.5 and u of n minus 2 into minus 0.5 and u of n, which is option B is correct. Question is, consider the following 8085 microprocessor program. Here we are loading B register with 00H whereas C register with 08H. We are moving the data which is unknown to us in D register is moving to A register. Now then after what we are doing is we are rotating the contents of the accumulator through carry, means the MSB of the accumulator register is placed in the carry flag. The jump on no carry instruction, see if there is no carry, it goes to skip, means that is decrements the counter by 1, that is decrements the C register by 1. If there is a carry, means this condition is not satisfied, hence it increments the B register. After decrementing the C register, it goes back. If C register contents is not 0, it goes back to again back label, that is again it performs the same rotation of an accumulator content through the carry flag. So from this logic what we understood is it counts the number of ones in a number which is present in the D register, and if there is a 1 in the D register, it increments the B register, means the contents of the B register shows to us how many number of ones present in the number which is present in the D register. Hence option C is correct. Question is, the impulse response h of n equals to e power 2n u of n minus 1 is given. We need to determine what kind of system is here, that is whether it is memoryless or memory, or the causal or non-causal, or stable or unstable. See, first we will check stability. Here stability means absolutely, that is this equation should be finite, this to this. Here if we substitute n equals to minus infinite to infinite e power 2n u of n minus 1, n equals to 1 to infinite e power 2n, this we can write 1 minus n equals to 0 to infinite e power 2n e square, the magnitude of e square is not less than 1, hence this summation is not converges. Means unstable or not stable. Here hence option D is correct. Here the question is, the NOR gate of figure below feeds 4 gates as shown below. What is the minimum value of beta to drive all these gates into saturation when V0 is high? Here, according to the question, Q1 is off, Q2 is on. Off means open, on means the transistor is in saturation. Here, first 4 minus V0, 500 equals to 4 of V0 minus 0.7 of 0.8 because VBE sat. This is VBE sat divided by 400. So 4 minus V0 is equals to 5 V0 minus 4. So 6 V0 equals to 8. From this V0 equals to 8 by 6 volts. From this the base current IB is given as, this is IC. IB is equals to 8 by 6 minus 0.8 divided by 400, that is 8 minus, here this is equals to 1.33 milliamps. Here IC equals to, that is the current through the Q2, that is 4 minus VCE sat of Q2, that is approximately 0.2 divided by 500, which is equals to 7.6 milliamps. So beta min equals to IC by IB, which is equals to 5.71. Here option D is correct. Question is, consider the network diagram given in the figure. Find out the value of V1. In order to find out the value of V1, apply the KCL at node A. That is V1 by 20 plus V1 minus 10 by 20 plus I1 equals to 0. Here V1 minus V2 equals to minus 1 volt. This is equation 1, this is equation 2. Here V2 equals to 10 I1, this is equation 3. Here B is V1 minus 10 I1 minus 1, that is V1 equals to 10 I1 minus 1. So if we substitute equation 4 in equation 1 and solve for V1, then we will get V1 as 2 volts, which is option B is correct.